Section 6.1, Power Series and Functions. So a series of the form, this here, is a power series centered at x equals 0. And this other type here, where you have the series Cn x minus a to the n equals this sum here, is a power series centered at x equals a. Now think of this, if I had the function x squared, so this would be y equals x squared. Now if you look at this one down here, let's say I'm talking about the function y equals x minus 2 squared. So that means what makes this 0? 2 does. So that means I'm going to shift it to the right 2 and then redraw the same picture. So again, that's how that works. So when I see this x here, that's centered at 0. And when I see the x minus a, that's centered at a, positive a. And then if this was a, let's say this a was a negative number, let's say this was a plus here, then that would be a negative a. I can think of it that way. Okay, so that's going to serve us well later on once we start getting into convergence and actually what it means when these functions converge, what it means geometrically. So anyways, let's move on. Okay, so now this theorem says it's the convergence of a power series. So it says, consider the power series. The series satisfies exactly one of the following properties. The series converges at x equals a, that's the first one, and diverges for all x not equal to a. And the second one is the series converges for all real numbers x. So on the entire real number line, this series will converge. And then there exists a real number r greater than 0, such that the series converges if this condition works. It's the absolute value of x minus a is less than r. And if I was to write this as a compound inequality, which I can, this would actually be negative r less than x minus a less than positive r. So that's what this is really saying here. So it's saying that x minus a is between negative r and positive r. That's what that's saying. All right, and then it says it diverges if it's greater than it. So that means if I'm outside of that area. So that means it would be the other way, like I would have these kind of conditions. And then in there would be r and negative r. And then outside of those conditions, that's where this would diverge. And then at the value of x, where x minus a is the absolute value that is equal to r, the series may converge or diverge. And that's going to be where we're going to have some of our issues at, is we're going to have to understand that when it's equal, we don't know if it's going to converge or diverge. We have to check for that because it may do either. And we want to be more precise on those intervals, and that's what we're going to get into when we get into these problems. Now this says, consider the power series. The set of real numbers x where the series converges is the interval of convergence. So when we talk about that interval, it's the interval of convergence where it converges. And if there exists a real number r greater than 0, such that the series converges for the absolute value of x minus a less than r, and diverges for the absolute value of x minus a greater than r, then the radius, then r is the radius of convergence. If the series converges only at x equals a, we say that the radius of convergence is r equals 0. And if the series converges for all real numbers x, we say that the radius of convergence equals infinity. All right, so when we look at these, if it's just a, it's there, and it diverges everywhere else. I really like this diagram below because it gives you that nice visual. And then the middle one says, this says it converges for all x. So that's where r equals infinity. And this is where r equals 0. And this last one is finite. This is just on this interval, so my radius of convergence is just r. And then, like I said before, this is r equals infinity, and this one is r equals 0. And I really don't like to say r equals r, but I can say r equals r. Okay, that's just what my radius of convergence is. It's r, whatever that value is, and it'll be to here. Okay, and r would actually be just one of these. That would be my r. It's from the center. So I wouldn't count this whole interval. I would just count it from the center to the edge, and that would be my radius. That would be my big R. If r was a finite number.